Okay, so 4, 6, 7, 8. Yeah, good enough. Okay, so it looks like that, and it crosses the y-axis at 0, -8. Okay, so remember your x equals -2. That's your axis of symmetry. X equals -2. So the x value of your vertex. So if we drew an imaginary line down the middle, which we're going to erase later, if you have -2, -1 here, it's only one space away. If you go to this same spot and you move one space this way, it's going to be symmetric. So you can go right down to that point. And at 0, if you go down to -8, if you stay at -8, because you know to get from -2 to 0 is 2 spaces. If you go 2 spaces over, you can just go down to -8. Now, make it a little more symmetric. Okay, so once you have 1/2, it's symmetric on both sides. So all you have to do is count the number of x values, and it has the same y value. That's where the axis of symmetry kind of comes in handy. All right, so any questions on that one? All right, well, on Newton, all you have to do is kind of guide the graph, so you won't have to worry about drawing it. So. Okay. Leave that up for a few seconds. All right, anyone still writing? Oh, okay. Okay, so let's say, for example, you wanted to graph y equals x squared minus 2x minus 8, but this time they want us to plot the y-intercepts. Which is really just a hint that the y-intercepts will actually exist for this one. Oh, should have been x and y-intercepts. X and y-intercepts. Okay. So it's already in the form we need. Y equals x squared minus 2x minus 8. Here we know our a is equal to 1. Our b is equal to -2. And our c is equal to -8. Okay. Remember your second step is to find your vertex. Okay, so we know for our vertex, we kind of separate that a little. Your x is going to equal -b divided by 2a. This is going to equal -2 divided by 2 times 1, which gives you 2 over 2, which is 1. Okay, so we know the x of our vertex is equal to 1. Now our y, which is just our f of x, the y of our vertex is just going to equal all of our x values for 1. Okay, so if we have 1 squared minus 2 times 1 minus 8, that would give us 1 minus 2, minus 8. So negative 10 plus 1 is negative 9. Okay, so we know our y is negative 9. So that means our vertex is 1, negative 9. Okay, so we have one of our points. So this particular one wanted us to graph using the intercept, so we'll use the intercepts. Go ahead and separate that a little. Let's say get the intercepts. Okay, so remember our x-intercept is when y equals 0. So that gives us x squared minus 2x minus 8 equals 0. Okay, which just becomes x minus 4x plus 2 equals 0. Okay, which means that x minus 4, bless you, can equal 0, or x plus 2 can equal 0. Okay, so we add 4 to both sides. You know that x can equal 4. Subtract 2 from both sides, x can equal negative 2. So we have two x-intercepts here. Because remember, your y is equal to 0 for both of them. So your x-intercepts will equal 4, 0, and negative 2, 0. Okay. Now for our y-intercept, we make our x equal 0. Okay, so that means we have y equals 0 squared minus 2 times 0 minus 8. We'll bring that up some. Which means your zeros both disappear. So you have y equals negative 8. Nope, actually, I have to actually put it into an intercept form. That's just our y value. Okay, so that means our y-intercept because remember our x is equal to 0, so that would be 0, negative 8. Okay. So we have our 3 points. All right, and we'll draw it on the next page, so I'll leave that up for a few more seconds. All right. Okay, so for our fourth step, we know all of our points. We have our vertex, which is 1, negative 9, not the other way around. Okay, we have our x-intercepts, which gave us 2 points. So we have 4, 0, and negative 2, 0. And we have our y-intercept, which is 0, negative 8. Okay, so we just go ahead and plot all 3 points, then we connect our dots. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Since we're going down to negative 9. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have our x and we have our y. Okay, so our vertex is 1, -9. So 1, -9 is right here. Okay, our original equation, remember it's y equals x squared minus 2x minus 8. Your a is equal to 1. So that means your a is greater than 0, so it's your vertex is a minimum. Because it opens upward. Move that over. Okay, so since we know it opens upward, we don't have to worry about going the other way. Okay, so we have 4, 0. So 4, 0 is right here. And we have -2, 0. So -2, 0 is right there. Okay, and you have your y-intercept of 0, -8. So 0, -8 is right there. Okay, so since we know this is our vertex, it just goes up. I guess you can say that way. And that way. So it looks probably a little more narrow than that, but I think I curved it a little too much. Get up and bring that one up. Good enough. But you kind of get the idea. All right. So any questions on that one? Like I say, you won't have to actually draw it. It's all you have to do is connect your dots and use the program to draw it for you. So yours will look a lot better. All right. So everybody's okay on this one? All right. Okay, so now we're going to actually solve story problems that want to know minimum and maximum values, which is really the same approach. Everyone's still writing. All right. Okay, so minimum and maximum values of a function. Just a quick reminder. That when a is greater than 0, the vertex is a minimum value. And when a is less than 0, the vertex is a maximum value. Well, in this case, opens upward. Opens down. Okay, so let's say, for example, should be able to finish it on this sheet. Find the minimum or maximum value of the function f of x is equal to 10x squared plus x minus 9. Okay, so the first thing you want to notice is that for your 10x squared plus x minus 9, your a is positive. Okay, so between a minimum or maximum, you know if your a is positive, you're going to have a minimum. So the quadratic function has a minimum. Okay, so once again, we know that before we calculate anything, just by looking at the a value. Okay, so to find our vertex, might as well say this is your first step. Your second step, you just have to find your vertex. Kind of separate that a little. Okay, so remember your x value of your vertex is negative b divided by 2a. So your b is equal to, actually should have put that up there. So your b is equal to 1, and your c is equal to negative 9, and your a is equal to 10. Okay, so you have negative 1 divided by 2 times 10. Which is negative 1 over 20. Okay, so we know the x of our vertex is negative 1 over 20. Okay, so now we have to plug that in to our function. So f of negative 1 over 20 is equal to 10 times negative 1 over 20 squared plus negative 1 over 20 minus 9. Okay, so that gives us 10 over negative 1 over, well, 1 squared is 1. Oh, actually that becomes positive because it's squared. Okay, so that's times 1 squared, which is 1. 20 times 20 is 400. Well, might as well say minus, since that's plus negative. So it's minus 1 over 20 minus 9. Okay, so the 10 and the 4 can be simplified. 10 divided by 10 once, and 400 divides by 10 40 times. So this becomes 1 over 40 minus 1 over 20 minus 9. Okay, so we can't subtract anything until we get all of our common denominators. So we can make all of the denominators equal 40. Move that up a little bit. Okay, so we have 1 over 40 minus 1 over 20, which we can multiply by 2 over 2, minus 9 over 1 times 40 over 40. Okay, which gives you 1 over 40 minus 2 over 40. 9 times 4 is 36, so 9 times 40 is 360 over 40. Okay, so negative 360 minus 2 is negative 362 plus 1 is negative 361. So you have negative 361 over 40. Okay, so that's actually your highest value. Right, so just to visualize it, if your graph looked like that, your x would be negative 1 over 20, and your y, well, actually it would be, negative 361 over 40. Oh, thank you. I don't know why I put the negative for there. Yep, 10x squared. Yep, so it looks like that. Okay, so you know your vertex is a minimum value. All right, so any questions on that one? Okay. Leave that up there for a few seconds. All right, anyone still writing that one? Okay, so let's say for our next example, a landowner is building a fenced-in rectangular patio. Well, I guess you could say, put it all in one sentence. Using his garage as one of the walls, so to speak. Okay, so he wants to maximize his 80 feet of fencing material. Okay, so just knowing that, we know the quadratic function of the area of the patio. The area of the patio is a of x is equal to x times 80 minus 2x. Where x is the width of one of the sides. Okay, so you want to find the maximum area. Okay, so if we wanted to visualize it, which you don't have to, but let's say this is the garage wall. And this is your fence. Okay, so we know the area is length times width. So this can be either 8 times 80 minus 2x or x times 80 minus 2x. 80 minus 2x. So you have your length and your width, which is how you got your area. Okay. Now you really don't need the picture to solve the problem, but it kind of helps a little bit. Okay, so remember your first step is to make sure it's in quadratic form. So if they gave you a sub x is equal to x minus, x times 80 minus 2x. And we go ahead and distribute our x. Then that's going to equal 80x. minus 2x squared. Or if you wanted to, you can make it negative 2x squared or plus 80x plus 0. You don't really need the 0 because once we find our vertex, it's not going to use it, but it's one of those things that's good to know. Okay, so it's in our quadratic form. So your second step, you're going to find your vertex. Okay, so we know our vertex means that x is going to equal negative b over 2a. Okay, so here we know a equals negative 2, b equals 80, and c equals 0. Okay, so our negative b divided by 2a is negative 80 divided by 2 times negative 2. Okay, which is negative 80 divided by negative 4. Clean that up a little, which gives us positive 20. Okay, so we know our x of our vertex is equal to 20, and all we have to do is plug that in. Okay, so not f, a of 20 is equal to 20 times 80 minus 2 times 20, which is equal to 20 times 2 is 40, so it's 20 times 40, which is 800. Okay, so that's the maximum you would have for your patio is 800 square feet. Or the maximum area. If you had 80 feet of fencing material. All right, so any questions on that one? All right. Okay, leave that up for a few more seconds. Okay, so now, might as well restart it since it's going to